Hi children, welcome to the video. In the previous video, we have discussed about what is spherical mirror, what are the types of spherical mirrors, convex mirror and concave mirror, what are the ray rules involved in order to form the images due to the objects placed before the spherical mirrors, what are the terminologies which are actually involved in order to study the behavior of image when the object is placed before the spherical mirror. So in order to study in clearly about them, you can watch this video which I am leaving in the cards. In this video, we are going to discuss about the image formation due to the spherical mirrors which are concave mirror and convex mirror. So before going to the image formation due to the spherical mirrors, let us recall the ray rules. The ray 1 says whenever incident ray is parallel to principal axis, it reflects and passes through focus. Ray rule 2 says whenever the incident ray is passed through focus, it reflects and passes through parallel to principal axis. The third ray rule says angle I is equal to angle R at any point on the spherical mirror. That is even valid for any type of reflection. This angle is equal to this angle, angle I, angle R. In similar way, the application of third ray rule can be considered as a fourth ray rule, ray 4, where whenever the light ray is incident through center of curvature, it retraces its path. Why? Because angle I is equal to angle R must be valid here, and center of curvature in the sense it is the radii of the spherical mirror. And if you have doubt what is this radii and what is this normal, you can check the previous video. Now, before diving into image formation, the one more point which we have to discuss is the difference between virtual image and real image. So, virtual image and real image. What is a virtual image and what is a real image? In definition, virtual image is formed whenever the extended reflected rays meet or intersected. Okay, this is formed due to intersection of extended reflected rays. This is formed due to intersection of real reflected rays. Okay, now this virtual image can be caught on the mirror or on the lens. Okay, but it cannot be caught on the screen. Is that so? Yeah. Caught on mirror, lens, etc. But this real image can be caught on only screen. It can be a white screen or any type of screen which actually shows up the reflected rays on it such that it forms an image. So virtual image, real image, and the general difference which we discuss in the image formation is virtual images in the image formation of spherical mirrors or spherical lenses, the virtual images are always erect and the real images are always inverted. This is a point which is valid for the cbse and other boards even, which should be mentioned. But in real world conditions, If we want to get a inverted virtual image, what should we do? We will take an inverted object itself. Okay, so please to remember the differences between this virtual image and real image. Now let us dive into the image formation due to concave mirror. The image formation due to concave mirror. Image formation due to concave mirror. So, image formation due to concave mirror. So here, before discussing what are the cases involved, let us discuss about some of the reference points which we have discussed yesterday. So if I consider a convex or concave mirror, I am taking a concave mirror. You can even take a convex mirror also. Pole, focus, center of curvature. Okay. So now, if I keep the object on this principal axis, okay, an image can be formed. So beyond C can be taken as a reference. If I keep the object on C, yeah, image can be formed, that is taken as a reference. Focus is taken as a reference. Between C and F can also be taken as a reference. Between F and P can also be taken as a reference. Whereas we cannot place the object on P, because you cannot place the object on mirror and find its image. Practically that is not possible. Okay, but here we do have one more reference, that is infinity. Obviously, right? Even not only on the principal axis, if you keep the objects somewhere, also the images also can be formed. Okay, so now for the concave mirror, what are the possibilities? The first possibility is, which we discuss about cases. If we discuss cases, the first one is object can be kept at infinity. Object can be kept at infinity. What is the second one? The object can be kept at beyond C. The object can be kept beyond C. The third one is object can be kept on C. The fourth one is further front towards the mirror between C and F. Between C and F. And the fifth one, on focus. On focus. Sixth one, between F and P. Between F and P. These are only the possibilities from infinity, but we cannot put any object on the pole because it will never form the image of it. Clear, no? Yes. Now the image formation due to the concave mirror, case 1. Okay, the first case. Case 1. In the case 1, what did we discuss? The object is kept at infinity. Let us take a concave mirror. Pole, focus, center of curvature. Object is somewhere in the infinity, so it will not be in this frame, or it will not be visible in the frame in which we are looking into it. So by using the simple ray rules, I have said to you, using the simple ray rules, we can form the images of the objects which are kept before the spherical mirrors or lenses. The first ray rule, incident ray parallel to principal axis when the object is at infinity reflects and passes through focus. Even the other ray we will take and it will also pass through the focus. Okay, now these reflected rays are meeting at focus, and that ray which is coming from the head after reflection is coming down, and that ray which is coming from the tail after reflection is going up, and hence here head is coming down, tail is going up, inverted image is formed. And how is its size? It is of point sized. Where is it formed? It is formed on focus. Which type of image is this? It's a real image, because the real reflected rays are intersecting to form. Okay, now if we discuss about the characteristics. if we discuss about the characteristic, the first point is image is formed on F. The second point, how is the image, Nana? It is a real image. What about third point? It is inverted. It is inverted. And what is the fourth point? It is point sized. Point sized image. See how simple is this? Clear with this? No? Now my question is like, what if I place a bulb over here? Oh, one small electric bulb. Okay, and it is given some proper voltage. Now what will happen in this sense? The light rays from the focus. So when this is kept at focus, the light rays from the focus are incident onto the concave mirror and they are reflected parallel. So you have found or you have studied one application, that is why a concave mirror is used in the reflecting. Why the concave mirror is used in the reflecting lights or the headlights of a vehicle. Reflecting lights or the headlights of a vehicle. Now again, one more smaller application. Now from the sun, let us consider some light is coming from the sun. Some light is coming from the sun and it is going to be a parallel beam onto this concave mirror. Now when it is a parallel beam, what will happen? They reflect and pass through the focus. Now if a smaller object which has to be cooked or heated is kept here, it will get heated up or cooked. And that application is a solar furnace. Clear, no? Now if you keep any body which is to be burnt or which is to be heated at the focus of a concave mirror, and if you incident enormous amount of light parallelly, that will get heated up. So two applications we have learned here. The first one is why concave mirror is used in the headlights of vehicles. The second one is why concave mirror is used in as a solar furnace. Clear, no? Now let's come to the second case. Let's come to the second case. Case 2. In this case 2, the object is placed beyond C. So let's take a concave mirror. Pole, focus, center of curvature. Object is placed beyond C. Now the hero will come into action, into the frame. Okay. Now simple ray rule. Incident ray parallel to principal axis, reflects and passes through focus. What is the second one? Incident ray, incident through focus. This reflects and passes parallel to principal axis. Now here the reflected rays are actually meeting. You may ask me, sir, why are you considering only the rays from the head? Why not from the tail? So from the tail, even if you apply ray 1 parallel passing through focus, second ray 2 incident through focus parallel to principal axis, angular passing through center of curvature, it retraces its path. So obviously we are not going to consider the tail always, because all the ray rules are being by default applied on this tail of this object. Clear, no? Now if you consider the characteristics of this image, characteristics. So if you consider the characteristics of this image, how is the image? So where is it formed first? It is formed between C and F. Okay, it is formed between C and F. Now how is the image? It is inverted, right? It is inverted, it is not erect, it is inverted. Now what about the size of the image? It is smaller compared to the object. The technical word here is used is diminished. It is diminished. Is it real or virtual? Real, because the real reflected rays are forming the image. So this is real. Okay, yeah, this is about the case 2 image formation. Now let us study the case 3 on C, which is a very interesting case and can be asked as a question in any of your exams. So case 3, now the object is kept on C. Now the object is kept on C. Pole, focus, center of curvature, kept on C. Now incident ray rule, simple ray rule. Parallel to principal axis, reflects and passes through focus. Now incident ray through focus, reflects and passes parallel to principal axis, and now the image is even formed on C. See how simple is this? Okay, now why the question can be asked and how the question can be asked. They may ask you, for a concave mirror, when is the size of the object is equal to size of the image? When is the size of image is equal to size of the object? Whenever the object is placed at the center of curvature. Now let us discuss about the characteristics. So if we discuss about characteristics, what is the first one? Where is it formed? At C. Second one, is it real or invert? Is it real or virtual? It is real. What about size? Same size. Okay. Is it erect or is it inverted? It's inverted. Okay. This can be asked for a 2 mark question. Now, if we discuss about case 4, where the object, see, if we carefully observe, in the first case, it was point sized. Next, its size has been increased. But compared to the object, the size of image is lower. Now the size of image is equal to object. What about next case? Size of image will be obviously bigger than the object. Okay, that we'll discuss now. Case 4, where the object is placed between C and F. So concave mirror, pole, focus, center of curvature, object is placed between C and F. Okay, it is placed between C and F. Now incident ray parallel to principal axis, reflects and passes through focus. Incident through focus also you can take, or even you can take normal incidence also, whatever, or you can take the incident at pole, it is also valid. I'm taking it through focus. So reflects parallel to principal axis, image is formed beyond C. See how simple is this? Just following simple ray rules only. Up to now we have followed first ray rule and second ray rule itself. Then now let us discuss about the characteristics. How are the characteristics now? First point, where is it formed? It is formed beyond C. Image is beyond C. How is the image? It is inverted. It is enlarged, or you can use the word magnified also. Next, is it real or virtual? It is real. How simple is this? So it's so simple. If you learn ray rules, no, obviously you will feel so easier to do all these image formations. See, some children will be like, soon after looking into all the 6 cases of this worm, oh, can I do this? Yes, you can easily do this. Just learn some simple ray rules and apply them. Just take care that the distance between F and P and F and C is the same. That's it. Follow the ray rules. Everything will happen by itself if you follow the ray rules. Okay, no need to remember like when it is infinity, focus, when it is beyond C, between C and F. Okay, and when it is on C, it is on C. It is when it is between C and F, it is beyond C. This kind of. This comes by practice. Okay. Now let us see the fifth case. Fifth case of image formation due to the concave mirror. So fifth case, case 5, where on F. Okay. Now when I say on F, some children will obviously have the doubt like, sir, how are we going to apply the secondary rule here? Obviously will not apply the secondary rule here. We'll go for the some other type of ray rule, because incident through focus, in the sense I have to take this much bigger size of concave mirror, and in pages which you write exam, no, if you complete the page only with a single diagram, that creates a zero impression. So that should not be done. So incident ray parallel to principal axis reflects and passes through focus. What about secondary rule? I cannot pass it in this way. So now I will go with an extension where I can use the third ray rule, whereas angle is equal to angular. I must take care that this angle is equal to this angle. This angle. Okay. So if I take care in such a way only, then this is valid, or otherwise I have to go for normal incidence, as we discussed, no, in the starting of today's class. So in this way, if I incident, normal incidence, so that will retrace its path in this way. So that also can be considered. Okay, but that is optional, because we require how many number of minimum rays? Only 2 are required, no? Why should we go for 3? Or if you go for 3 also, that's not an issue. But minimum number of required are 2 only. That's why we won't consider the third one for now. Okay. If you see these rays, they are moving towards each other, but will not meet on this frame. So obviously they will meet at infinity. When they meet at infinity, the size of the image will be very bigger. Real rays are meeting, obviously they will become a real image. Right? So now write the characteristics. The first one, where is the image formed? At infinity. Image is formed at infinity. What about the second one? Is it inverted or erect? It is inverted. I said to you, wherever there is inverted, there is real. Obviously, this is real. And what is the fourth point generally we discuss? Come and say to me. Magnified or diminished? So this is highly magnified, highly enlarged, or highly magnified. Clear with this now? And in order to catch this image, what should we do? We should use a screen. But when it is at infinity, obviously its intensity will be very less. But for the remaining cases, the intensity can be seen, and there if we use any screen, you can see the real images. That is what the activities in your textbooks state the same. Clear with this now? Now let us come to the sixth case, case 6, and this is a different case. It's not typical. This is a different case. Okay, where the object is placed between F and P. Pole, focus, center of curvature. Object is placed between F and P. Object is placed between F and P. Incident ray parallel to principal axis reflects and passes through focus. Okay. Now I can take angle is equal to angular, or I will go with normal incidence now. It seems to be a normal incidence, no? But this will retrace its path, because angle is equal to angular and normal incidence. Both of them will become 0. What both of them? Angle of incidence and angle of reflection. These rays tends to move away from each other, so they will never meet even at infinity. Reflected rays, they tend to move away from each other. If I ask two people stand beside each other and move with 10 degrees to the right and the other one to 10 degrees to the left, they will never meet. In the same way, these also will never meet. So what should we do? Not just extending, but here the virtual images are created in such a way they are enlarged. That means an extension of the reflected rays is required in order to form or to show the virtual image, and this virtual image is actually enlarged. Clear? No? Now let us write the characteristics. What about the characteristics? Where is the image formed? Behind mirror. Actually it will be formed on the mirror only, but if we consider the image distance, we can state it as it is behind the mirror. Now how is the image? Real or virtual? Obviously virtual. Virtual pair, what is that? Erect. Obviously it is erect. And last but not the least, is it diminished or magnified? It's magnified. Now one simple explanation. Now let us consider a teeth is placed over here. Oh, why teeth? Because dentists use this concave mirror with less focal length. Okay, and when he places this mirror in such a way that teeth is present between focus and pole, now the bigger image of the teeth can be seen. Are you clear? Okay, on the mirror itself, on the concave mirror itself. So whenever we want erect, virtual and magnified images, that too on the mirror, we should go for the application of sixth case of image formation due to a concave mirror. The best application is why dentists use concave mirror in order to check the teeth of the patient. Clear with this? No? So we have seen all the 6 cases and even the applications of concave mirror, and this case even has, it can behave as a shaving mirror also, because if you place your chin here, okay, before the shaving mirror, obviously then you will have a bigger size of your chin being seen on the spherical mirror, concave mirror, and then obviously the remaining things can be done. So these are all the image formations due to concave mirror. Okay, now before going to image formation due to convex mirror, we'll discuss some gradual differences between concave mirror and convex mirror. So if I take a concave mirror, the field view of the concave mirror is less. That means it can only get the light within its aperture, okay, or slightly more. Okay, but if you consider a convex mirror, this will get more amount of light onto this, and hence the area being covered by the concave mirror, the area of incidence onto the concave mirror is less, whereas convex mirror can actually cover more area. When it is actually taking more light, it can actually cover more area. So obviously here, say for example, if this can accumulate some 10 toys as the objects, this can accumulate even 1000 toys and more also. This is just a small comparison. It's not any equation or a proof. This is just a small comparison. Okay, this is an assumption. Okay, so that is why these convex mirrors are used in rear view mirrors. We'll discuss why they are used like so. Now let us discuss the image formation due to a convex mirror. Okay, image formation due to convex mirror. Image formation due to convex mirror. Okay, now let us take a convex mirror. Let us see what are the possibilities, what are the cases this can actually show the images for the objects. Pole. Now Where is the focus for convex mirror? It's a virtual focus, center of curvature. Can we take these as references now? You cannot take, because you are not going to incident the light onto the silver coating, which is unuseful. You should incident the light only onto the reflecting surface. Okay, right? So obviously, what is the possibility? We have a pole on the mirror and only infinity and principal axis. So two possibilities. On the pole we cannot keep, no, that's why only two possibilities. What are those? At infinity, on the principal axis. Only two cases, at infinity and on the principal axis. Yeah. So now let us see the first case. What is this first case? First case, case 1, when the object is at infinity. Let us consider this convex mirror, pole, focus, center of curvature. Object is at infinity, incident ray parallel to principal axis, reflects and passes through focus, but here it won't pass into the mirror, it's a virtual reflection on the focus. So if you take another ray, the same thing will happen, the virtual reflection will happen, and where is the image formed? On focus. Now if we write the characteristics, first point, on focus. What is the second point? How is the image? Point sized. Is it real or virtual? It is virtual. When it is configured as virtual, we know how it is. It is erect. It is erect. Clear with this now? Simple characteristics. And why do we have only two cases? Because P, though it is on the mirror, we cannot incident anything onto it except some light rays. We cannot keep the object there. Focus and center of curvature are inside. The case 2 of image formation due to the convex mirror. Let us see. Now the hero actually will come into play. Pole, focus, center of curvature. So he will be on the principal axis. This is the only case, right? Because on the pole we can actually incident the direct object, and we cannot keep the objects at the coated surface, before the coated surface, where the focus and center of curvature will actually be. So now when the object is kept on the principal axis, incident ray parallel to principal axis, reflects and passes through focus. Reflects and passes through focus. So this is a virtual reflection. This is a virtual reflection. Okay, now we require one more. Ray. That means we'll take a normal incidence. It retraces its path. Normal incidence in the sense, incidence onto the center of curvature. Now if you consider, this is how the image is formed. Now if you consider this image, how is the image? Image is virtual. The second thing is, image is diminished. It is smaller in size. The third thing is, it is erect. It is virtual, it is erect, it is diminished, and it is formed behind the mirror. So as we can say behind the mirror, but it is actually formed on the mirror itself. So if we write the characteristics, first point, behind mirror. Okay. Second point, virtual and erect are friends. Okay. And the last point, how is the size of it? It is diminished. Now, using your IQ, you must understand, as I have already stated, that this can be used as a rear view mirror, no? Using your IQ, you can say that, yeah, why it is used as a rear view mirror? Consider this is a lorry, and generally you people will see the smaller image of the lorry in your rear view mirror. Clear, no? Okay, so that is very bigger important point. So whichever the vehicle is coming behind your vehicle, you can see the smaller images of them. And the second most important point here to discuss is, what is that? It should have even wider field view, right? No, that's why convex mirror image formation, second case, where the object is placed on the principal axis. We have n number of principal axis for the convex mirror, which is used as a rear view mirror here. So all the bigger objects with a larger field view will be covered on the convex mirror, and the smaller images of them will be formed. Clear now? And one more application of this is, these convex mirrors are used in blind curves and used in shopping malls. Okay, and some other places also where more field view is required in order to form the images. So at the blind curve, say for example, I am coming on my bike or a car. So it's a blind curve. I am at 160 degrees almost, and here there is a convex mirror. So I have to come in this way to the curve and take a turn in this way. So now, even if I see from here, the objects which are present here also will be actually visible to me. In the general reflection only they will be visible, but when I use a convex mirror, more field view is covered. It covers me, it covers the space which is straight to the convex mirror, and even the vehicles or the road which are even on the right side to that convex mirror. So more area, and even it must accumulate more vehicles or whatever the objects are present in that area. Okay, so for that application, the convex mirror is a perfect use. What is that? If we want a virtual image which is smaller in size, and it must accumulate more field view, that means more number of objects in its area, in order to form the images of them. There, in those applications, always the convex mirror is used. Clear with this now? So we have seen the image formation due to concave mirror as well as convex mirror today, along with the applications of them. And if you are up to here, and if you feel this interesting, please do subscribe and support me, and you can share the same with your friends such that they will gain some knowledge for the same. Thank you. This is Naresh Ramraj signing off.